Alright, welcome back to Doozer Shop. Not too much today, just some updates on the Pratt & Whitney lathe and some of the things I've been working on. Alright, first off, the Pratt & Whitney lathe motor. If you look, it's 5 horsepower, 3-phase, 60 cycle, 1745 RPM. So it's an 1800 RPM motor, and you'll see it's rated at 208/220, and also wired, capable of being wired at 440. If you look at the very bottom of the tag, you'll see it's also dual rated at 5 horsepower, 50 cycle, 50 hertz, at a little bit lesser 1450 RPM. It's interesting. Typically, when the hertz, the frequency goes down, so does the power. So maybe it's a little less than 5 at 50, or it's a little more than 5 at 60. I don't know. But anyhow, Fairbanks and Morse is a decent quality motor for the day. These were top of the line as far as I can tell. So that's what it is. I didn't know if it was 3 horse or 5 horse, but because the lathe was optioned up to 1500 RPM over 1000, I suspected they might have given it the bigger horsepower motor, and sure enough they did. So that's cool. Alright guys, what I got here is I've got the compound from the Pratt & Whitney lathe mounted to the closing mill. So the reason I did that is this. Let me show you. So I got the T-nut made, mostly made except for tapping the threads, and fitted to the top slide, the compound. And the reason I did that, if you can see, the slot was just a bit mushroomed in, and you can maybe see I did minimal cleanup. I left some of the original looked to be horizontal milling cutter marks, and I cleaned that up. So so that's that side, and I did both sides. I don't know if you can kind of see here. The back side, you can see the minimum cleanup mark on the back, the background. That's the original surface that I buzzed with the end mill. So it was just barely not cutting there, and it cut the whole way to the front edge. So that's cool. And I got the T-nut and it fits like a dream, you know, the whole way. So I'm going to drill and tap the hole, but I thought I'd show you guys, you know, I had it in the mill here, and the last compound, I think I was doing the Colchester 17, I had it in the SIP jig bore, but kind of see, maybe I just got it bolted down on top of 2 parallels to the T-nuts in the slots here of the mill. I just got lazy. I didn't take the vise off. You can see I got another parallel there, and I got a bolt, you know, right there. And you may ask yourself, why did I do that? Well, it's got a little proboscis sticking down there that, you know, sockets into the cross slide of the lathe, so made it necessary to put this up on parallels. So that's cool. Wanted to show you guys, you know, basically my setup there. I didn't show you the milling, but you kind of get that, I'm sure. So there you go. One more thing here. I think I mentioned this before. These oil cups, this one and that one, you know, they oil the slideways, the dovetail slides of the compound here, the top slide. And also what they do is they oil the top part of the lathe. So the top part of the lathe is the cross slide, right? So there's the cross slide, and there's that hole where that piece of the top slide sockets into. So you'll see, man, I can show you there's the lead screw. Looks to be left-hand thread right there. This is the oil trough, right? And these are the little restrictors. Looks like that one's for the crossfeed nut. And these are for the, you know, the crossfeed ways, right? So that looks like it drips it on the dovetail angle, and that's on the flat. That one's for the dovetail angle, and that's for the flat. But anyways, if you notice, the oil's in the T-slot. It's not in this little collection slot. This is actually bone dry, so I'm glad I figured this out. So somehow, either I'm not lining something up when I'm oiling it, or what. So I got to look into that. Usually it says, like on your rocker, it says oil rocker at this end of box, right? So you got to put the quick change arm down there. And then this is kind of a goofy oil cup because it's sideways. It could probably stand to use a, you know, a 90-degree one, but we'll see. We'll see how it works. But anyways, I got to see why that's not oiling. It's either plugged or I just didn't have it lined up. So we'll see, you know, what that all is. But oh, speaking of which, I got these on eBay. These are well, I took the plugs out. I had a metal steel plug on the side, and this is a plastic, just a crappy plastic plug. So the plastic plug was in here in the front of the apron, right? And it's 1/2-inch pipe thread, 1/2-inch American pipe thread. So now I got a nice big 1-inch flip top oil cup, so I can keep the oil level maintained in the apron without a squirt bottle. I don't know how they expect you to do that. Probably, my mind, I'm thinking like a 90-weight gear oil comes in a squeeze bottle with a little nipple spout. And I got one here. You know, this had a, you know, just that standard variety pipe thread plug, 1/2-inch pipe thread plug. So we got a nice flip cap oiler there. So I thought that was a good purchase. Oh, I got rid of that shoulder screw or stripper bolt or whatever you want to call it. So now I got a nice bat handle, right? So this had the bat handle there, and I got a bat handle here now on the cross slide. So you know, you're carrying the theme through. It probably had originally a bat handle. One other handle modification I did was the lock handle for the tailstock here, right? It had a ball on it, and I really wanted this to be a little bit longer, right? For leverage, and you're reaching your hand over it, and it just seemed like that ball was too small. And by using this, you know, I call it a bat handle because it looks like a baseball bat or something. You know, by using this type of handle, it gives me a little bit more length to the binder lever for the tailstock. So that's cool. That's neat. I'm quite pleased with the look of that, the feel, and the function of that. This lathe, I'm really hip on the feel and the function. Another thing I've been working on, this is the taper attachment, right? So this is the ball bearing sled, right? It's got these rubber wipers and roller bearings, right? Sled, I guess it's more of a shuttle. But anyways, I got the whole taper attachment cleaned. I had used lacquer thinner on blue paper towels and I wiped it clean. And I don't know why that's not going in. Anyways, I'll figure that out. But that's what I'm sorry, I'm turning. It's got a gear rack underneath, right? And by turning this rack and pinion, you know, the whole thing angles, right? Pretty cool. So this thing was really greasy. I want to give a shout out to Kroil, K-R-O-I-L, or aerosol version is Aerokroil. I sprayed, it's expensive, so I just used a very little amount of that Kroil, and I got this thing moving. I started tapping it with a shot-faced rubber hammer, shot-filled rubber hammer, shot-filled rubber-faced hammer. How's that? So that's neat. If I gotta, now can I show you? Where the heck is it? Somewhere. Oh, I think it's under here where the connection is. I got to run the cross slide back. The only other thing I'm going to do on the Kuno oil filter, that's the fill, and that's a little plastic half-inch pipe thread plug. The two I bought for the apron in the front there, on the quick change box, were 90-degree Gitz oil cups for this half-inch pipe thread. I need a straight Gitz oil cup for that. So I got one, and it's not half-inch pipe thread, but I might maybe adapt it. So that's what's going to go on with there. But yes, this thing is, I mean, it moves like butter. It's all clean. I mean, I've got some schmung and some grease in, you know, the voids down there, but so this is a binder that locks it, right? When you position it, you tighten that up. It's like, see the slot? That's half-inch wrench is what that takes. I mean, you could use an open end wrench or a crescent wrench. I want to get an engineer's wrench. I think there's one on eBay for 15 bucks. That's half-inch square. That's half-inch square that allows it to move in the, you know, the master location in the T-slots. So, but anyways, yep, I don't know if I had last time. Got my chuck fitted there. I had that in the drawer, and I just think that bat handle extends the binder lever on the tailstock, and it's a simple little silly modification, but I think that's going to make it more of a user-friendly experience to run this thing. All right, I'm going to put the camera down. I'm going to unbolt the top slide, the compound from the milling machine, and see why those oil holes aren't working there. What are you doing, Doozer? Well, I'm not quite sure myself. But this is the top slide from the Pratt & Whitney lathe. And just checking it for clearance. I'm drilling a hole dead center for a location. And I'm going to show you why in a second. It's close to hitting everything. Lathe is as slow as it'll go. I'm just going to try and transfer a center location, so here we go. There. It's kind of all I wanted to do. I don't think I should push my luck. It's pretty good. And let me bring you back and I'll show you exactly Oh, I should tell you, that spigot on the back is how I'm clamping it. That pilot register, that spigot, is clamped in a 3-jaw here. So this hole is exactly center of the swivel axis, and I just need a hole to lay out some locations, and I'll show you in a minute. Alright guys, we got it figured out. So this hole in the center is exactly 2 inches. Okay? So I'm trying to figure out a radius I can drill my oil passages at. Eyeballing to the center of this cast trough all the way around, the average I get is 8125. And that's going all the way around, making sure it's as close to the center as possible, even though this is a cast trough and it does deviate a little bit. So I'm pretty precise with that number. And I think that's 13/16. So what I'm going to do is make my radius 1.8125, because that's a 2-inch hole, 2-inch plug goes in there. So the radius is 1. So if I take my dimension here and I add 1 to it, that's my true radius to the center of this trough, to the center of the where everything emanates from the middle there. So that's what I got. So I know my radius is 1.8125 from the center, and that's what I had to do on the compound. Let me kind of show you. All right, let me so that's the hole I drilled on the lathe. That's the center of that plug that fits into the cross slide. So that's only, I don't know, 1/8 of an inch deep. It was just enough to get me centered on this side, transfer my center to this side. Now as you can see, I drilled a 1/16 hole in that oil passage right there at a 1.812 radius. So I used a spring caliper, and I laid out exactly that radius to there, and I laid out that radius from there over to that one. So you can kind of see in the oil groove it has that transfer hole, okay? And that oil groove, right, it has the transfer hole, okay? And it was all emanating, and that's just a center hole for measurement. That's all that was about, okay? So that's what I got. And you can see the oil grooves, which is fed from the top slide. All this is fed from the moving top slide. This is the bottom part of the compound. The upper part of the compound is where the oil comes from. So now that I have that, let me kind of just flip you over. You can kind of see the staining where that trough is, right? So that little center hole is coaxial, shares the same axis with this 2-inch protrusion locating boss, whatever you want to call it. And so I got basically that's the hole that breaks through from the ways on the other side, and you can see there's that staining, and over here as well there's that hole that I drilled from the other side. So both of those holes land in the trough, not the, yeah, they basically they land in the where it's going to be centered over that cast feature to port oil to the cross slide. So the top slide receives oil and passes it through to the cross slide. So that's going to work pretty well. And I only drilled them a 1/16 because I didn't want to completely drain the oil. from the top slideways. But at least it's connected now. It's connected there. And it's connected there. So that's, I think, how the factory was supposed to do it. I don't know what the deal is, but that's going to work really nice now. Let me get this cleaned off really well, and I mean, I'll throw a little chamfer on there and a little chamfer on that one to make sure everything's not, yeah, it's got a little burr there. Let me get it stoned off and we'll get you back. Alright guys, while I'm thinking about it, I wanted to show you some other oil holes that were actually clogged. Can you see down in the depths of that T-slot for the bolts? There's a hole in there, right? And actually on this side too, you can see the ways underneath. So that's a drain, an oil drain for the T-slot. And those were plugged up with like mud daubers, who knows what it is. But yeah, all these are connected. You can blow air in there and it kind of shoots out the way interface there on the flat way. So there's the flat way, there's the dovetail angle, there's the dovetail angle, there's the flat way, there's the nut, and everything seems to be connected. So let me put the top slide on there and we'll see how it goes. Alright folks, there we have it. Let's put it back on the lathe and see our ways connect right there and right there with them holes. So no matter where this is, those are going to be lubricating down where it needs to be. So put the rest of it together. Alright, we've been a bit busy. So I've got the T-nut completely finished out, completely finished up. Came out really well. You can see I undercut the T-slot a little, the T-nut a little bit, as not to bear in the corners. How important is that? Not very. But anyways, so that's the T-nut. And half 13, I tapped it 99% through instead of Loctiting it. The other one I Loctited when I made it for the Colchester because I went too far. So that's cool. I think it's going to set right there. And the AXA is too small, but I made this riser. I calculated I need a 5/8 riser, and this one is 11/16, so I could take a 16th off of this. I surface ground it front and back, but I might end up taking off a 16th later. I don't know. So this should probably be a BXA or a CXA. So that goes on there. Kind of see how everything fits up. It's a 2.5 inch diameter spacer, so that seems to be about the size of the tool post. And I got a Tico nut here, like I said, half 13. Eventually, you know, I might do something fancy schmancy like that, but for now, that's going to be awesome, right? And it fits super nice. There's a little gap at the top, so as the spacer is not, or the tool post is not on the The T-nut, there's about 20 some thousandths in there, so we tighten it up properly. We got new heavy hex nuts and heavy pattern washers here. They had light pattern nuts and just crappy ass washers. So that looks proper. In the Pratt & Whitney literature, it says this top slide is not a casting, it's actually a forging. So that's extra heavy duty forged steel, not cast iron, but this is forged steel. And it needs it because, man, over the years it's taken a hunk of chunking. So there I go. That's pretty good. Here is, I had these on my 10-inch Atlas back in the day, right? How time flies. And I've been matching it up, you know, to see, you know, how much center height. So you can't see it, but it's very close to being on center. And you got to kind of look, is the dovetail centered or in the bottom? It's a little bit towards the bottom of the range, right? So if I shorten up that spacer another 1/16, I think I'll have it. The tool holder will be centered on the tool post. But either way, so that's where I'm at with that. I'm pretty happy with that for now. And I think I'm going to put the same AXA on the Hendy. And I think the Hendy is higher where I won't have the spacer. But anyways, and now these Gitz oiler cups are hooked in, so they oil a cross slide, so that was important to get that figured out. I'm surprised the factory dropped the ball on that. They just weren't connected. So anyways, that's what I've been working on. Yeah. So essentially this thing's ready to cut. This is ready to cut metal right now. I got my chuck in there, I got a live center for it, I got a dead center for it, got my tool post, I got tools, I got tooling. I could turn this on and make parts right now. So banner day here this evening at the shop. So thought I'd show you, and I might, you know, I got thrust bearings that I could put under here. My stud's not long enough. I just grabbed a stud out of the milling clamps drawer. But, you know, these are a ball bearing type thrust. And I might do that, but I just got this sitting here for now. All right, that's it. Good evening from Doozer Shop.